Hello, it's Keith here, and this is lesson 24 of the platform-specific series of my 68000 assembly tutorials. This time we're going to be looking at hardware sprites on the Sharp X68000. Now this system was based on arcade hardware, and I believe it's actually used to develop some arcade games, and so obviously it has some pretty impressive sprites. Now personally I'd say they aren't quite as good as the Neo Geo, but certainly very, very good, and certainly quite impressive for us to want to look at. So let's start discussing what they can do. Well, the system is capable of, I believe it's 128 sprites. These have memory mapped addresses that will control the position, the sprite tile, the color, and flipping and also layer priority of the sprite. In addition to the actual positioning and other attribute data, of course, there's bitmap data. This is located from EB800 onwards, and this will define the data of the sprites themselves. Now the sprites are in a sort of traditional format, they're not in bit planes, and so each color is 4-bit, and this gives us of course a total of 16 colors. Now the sprite itself is 16 by 16, but it's split into 4 chunks, so each chunk is delivered sort of separately. So first is the top left, then the bottom left, then the top right, then the bottom right. So you can kind of imagine them being split into these 4 chunks. Now of course you can create your own data just fine, but if you want an easy way of exporting a sprite in the correct format for the 68000, then I'd suggest you might want to consider my Acru Sprite Editor, which is what I use in my tutorials to create the bitmap sprites that we're going to see today. So if we go to the 68000 menu and X68000, we've got a Save Sprite option, and this will export into this format just here. So we do have that as a way of getting the valid data if we want to. So we've got our bitmap data at EB8000, we've got our attributes at EB000 here, but we do also need to set a few screen settings just to make sure sprites are going to work. So basically we need to make sure we set all of these attributes just here to configure the sprites to work, and these will vary depending on our screen resolution. Okay, so let's actually see the sprites working on the X68000. Okay, so you can see we've got this kind of coloured crosshair here, and hopefully you'll recognise that. We saw it just here because we exported from this to this. So we've got our sprite working here, and now we're going to look at the code and see how we actually get that sprite to the screen. Now I use a sort of set sprite routine here, and I pass a variety of parameters to it. So we've got the hardware sprite number, because of course we're controlling the settings of a sprite that's configured by the hardware, so we have to specify the number that we want to configure. So if we wanted to use 5 different sprites on screen at the same time, they could all have the same sprite pattern, but they would all have to have different sprite numbers, because otherwise when we tried to draw the second one, the first one would disappear. So we need to use a unique number to tell the routine which sprite to configure. We've got an X and a Y position, a sprite pattern, a palette, because of course these are 16 color sprites here, and so we can configure them to use different sets of 16 colors, and a priority, which we're probably going to want to always keep as 3 to keep them right at the top of the layer stack. Okay, so let's actually have a look at the code here. So we've got a variety of code here, and just depending on our screen resolution, we've had to add a few extra attributes here just to initialize the sprite hardware. So you can see these are writing to hardware registers relating to the screen. And I don't think you're going to want to ever actually change these settings unless you're sort of trying to use a more elaborate screen mode. So I've got this sort of set of recommended settings just here. It was a bit of a nightmare figuring these out, and I had to go and read a Japanese manual to get the answers in a lot of cases. So I'm hoping these will just do the job as is and make things a little bit easier for you than it probably was for me originally. But anyway, as I say, these should get sprites working for you in the way you're typically going to want them to work. Now, the first thing, of course, we're going to need to do is actually get the bitmap data of our sprite that we want to show into the correct location in memory. We've got this definition of a label called sprite here, and you can see we're importing the x68 sprite just here. We're defining the pattern number we want to change, and then we're using a function called define sprite. And if we just have a look at that just here. And so essentially what we're doing is we're multiplying D0 by 128 so that we can work out the address of the pattern we want to change. We're then adding EB8000 to that, because that's the start of our bitmap data for the patterns. We're moving that into A0. We're then defining the amount of bytes we want to change. We want to change a total of 128 bytes, because that's the total of the 16 by 16 4-bit per pixel sprite. And then we're just doing a looped copy here to copy all of the bytes from our source, which is going to be an A3, to our destination, which is now in A0, calculated by the offset specified in D0. So that's how we actually set up our sprite in memory, and then all we need to do is actually just show it to the screen. So here we've got our code to do that, and it's pretty simple, of course. So again, we're taking the hardware sprite number and we're multiplying it by 8 because there were a total of 8 bytes at 4 addresses to set the attributes. So we're doing that there, and then we're copying the words into A0, which we've now got primed with the correct destination for the hardware sprite. We're copying the X position first to 2 bytes. We're then copying the Y position here. Then we're shifting the palette to the left by effectively 1 byte, moving it to these bits just here. And then we're adding D4. So we're adding D4 to D3 here, and now this means that D3 contains both our palette here in these 4 bits and also our sprite pattern data in this byte just here. We've also got options for vertical and horizontal flip up here that we could use if we wanted. And then finally we need to copy the 2 bits of our priority just here. Now each time we're writing, of course, we're incrementing the address by 1 word because these are of course consecutive, but that's really all we need to do to set up a sprite to be visible. Now the example we got just here is very crude, but we could of course make it a little bit more advanced. We could add a second sprite to the screen maybe. So if we just change this, we would need to change the hardware sprite number to maybe 1, because as I said, if we were changing the same one twice, we would actually remove the first one. And then if we run this now, you can see we've now got 2 sprites overlapping each other. And if I change the code just a little bit here, this time I'm going to increment D1, the X position, and wait for V blank, and I'm just going to loop around here, setting the same hardware sprite each time. As I said before, if we set the hardware sprite a second time, it will effectively move it from its original position, whereas if we used a different hardware sprite number, we would be adding more sprites to the screen. And now you can see we've got a sprite scrolling across the screen. Now it disappears when it gets to the end rather than kind of smoothly vanishing, and that's because I'm only setting a single byte, not a word. Because if you remember, because the X position is 10 bits, not 8, so I'm kind of doing the job a little bit crudely there. But anyway, I think you get the point. We can very easily with this get started with sprites, and I hope if you're going to try this, you will enjoy it and appreciate it, because I think this took me like a full day to get a single sprite showing on the screen, just because there's not a lot of documentation about it, and what documentation there is in Japanese. So there we go. Anyway, of course, you can go to my website. If you download the sources.7-zip, you'll get the AccuSprite editor, the source code for AccuSprite editor, the test sprites in an editable file that you can see here. It's called spritetest.txt, and also, of course, the source code for today's episode. So hopefully you'll have some fun with that. Anyway, that's really all we're going to be covering today. I hope you found it interesting. Please like and subscribe if you have, because we'll be coming back to the X68000 at some point, probably for multiple layers or something. And we're going to be looking at the Neo Geo next time to look at the hardware sprites on that system. Thanks for watching today anyway, and goodbye. If you enjoyed today's lesson, please check out my website. We've got tutorials, source code and development tools for 6502, 68000 and Z80 systems, and a lot more systems coming in the future. We're going to be covering the 8086 and the ARM and a few other things as well going forwards. And if you've liked this lesson, if you've got questions, comments or suggestions on how it could be made better, please consider signing up to my forum. It's free, of course, and you can come along here and you can make suggestions, you can ask questions. And if you've got assembly projects you're working on, please let us know what they are. Maybe show off a few screenshots, tell us what things you've found interesting or what tricks you've come up with, because we'd love to know about it. Anyway, thanks for watching today, and goodbye.